Hi everyone, welcome back to Dragonfly Engineering. So I'm here with April, who's running the camera behind you, and this week we're going to do an update on where we're at with the new injection molding machine. This is the Wu-Tang molding machine, 530 US tons, and we've actually made our first mold, an aluminum mold, and hung it on the machine and ran our first parts.
Yay!
Yeah, so it was about a 3.5 week process to rush this mold. Most of my customers need quick molds. And unfortunately though, we can't show the inside of the mold or the parts that were molded because it's their proprietary secrets, but we can show the closed mold. So we'll have to deal with actually passing through and turning the machine on so I can close the mold, because there are updates to the mold that needs to happen. But we could talk about what we had to do to make this molding machine work for our first parts. The first thing is the gantry crane, which I picked up at an auction about a year ago for, I think it was $400. Anyway, this is a 3-ton gantry with a 3-ton winch, and we had to raise the gantry crane even higher than what we did when the riggers came to install this molding machine, to basically get the gantry crane to be all the way up at the ceiling height. Now the ceiling in this building is actually slanted, so the lowest level of the ceiling is in the back of the shop where the roll-up door is, and then the highest level of the ceiling is at the front of the building, so that there's a rain slope on the roof itself. So there's about 2 more feet of clearance on the front side of the roof of this space than the back. So basically we had to roll the gantry in, get it up over the molding machine when we placed this machine on the floor. And then we wound up having to get really long 4x4 planks of wood and use a car jack, like a hydraulic scissor jack, to raise this gantry up another 2 feet once we got it inside of the shop. And the result is that, oh, actually here's the car jack we used. So imagine a 4x4 post being sitting on this area. The other end is up against the I-beam up there. And then we just jacked it up and we just kept advancing this screw 1 slot at a time until we maxed out the height of the gantry. Yeah, and that resulted in a clearance for our hook on our winch of 24 inches. So that was enough to load this mold, our first mold that we made.
Oh,
Anyway.
I think maybe we can also mention that whenever we moved in that video we had a couple weeks back, where we had the clamping part and then the injection part, and we made sure that we got the crane into the bay before putting the injection and clamping part together.
Yeah, the second half of the machine.
Right.
Yeah, it's kind of an order of operations.
Right.
So. All right, let's move around here. So basically this area is where I did the final assembly of the mold, and there's stuff everywhere because the whole shop was basically blown up with moving everything around for this machine to be placed where it is. So we need to reorganize basically the entire shop. But this gantry can roll all the way back to this area.
Oh, I see.
And we'll do the final assembly of the mold here. I'll probably get a big steel table that will be for mold assembly. And then that gantry crane can be used to lift mold parts. Like this is another mold. This is our desk organizer mold. And when you have big heavy molds, you need basically a gantry crane just to lift each part of the mold itself. So that's what's going to happen right here. And then when the mold is assembled, that crane will lift the mold up off the table, up over this sheet metal edge, and then we'll roll it with the wheels, which can lock into that just linear position over, and then load it into the molding machine. So like I mentioned, we do need to pull this mold, but I can't show the inside. So we'll go around to the front, turn the molding machine on so we can close the clamp, and then we'll hook our crane winch back onto the mold. and then uncouple it from the platens of the molding machine, and we'll lift it up and bring it back over here and set it right down on the floor. So we can go around to the front and do that. So again, this is startup, so nothing is quite where it should be. This is the plastic we were using. This hopper I picked up for free from the company that I bought this molding machine from, but it's a little too high. So if we actually add a vacuum loader onto the top of that hopper, there's not enough room for a vacuum hose to come down to the Gaylord of plastic, which is back here, to suck plastic up. So right now we were doing buckets and using the side hatch. I do have this other hopper that came with the dual shot molding machine, still in the bubble wrap. So we may actually put this hopper in place of that really tall one. Mm-hmm. And the bolt pattern didn't even line up or anything. So we'll have to figure out what to do about all of the hopper situation.
Oh, you mean the hopper that's in the bubble wrap?
The bolt pattern on this hopper didn't line up with.
Oh, really?
With the molding machine here. Doesn't quite fit.
Oh man.
The guy was saying that came off of there, but I don't think it did because we had to spend a while opening up holes and mounting holes and things.
Okay.
One cool thing is all of this hardware is kind of ancient, but this is a magnet array.
On the viewing glass?
Yeah. I think we're empty here.
Well,
we may have a little flood of plastic come out.
Yep.
But we'll find out. Nope, we're empty. Oh yeah, I actually cleaned this thing out. So these bars are actually magnets with like an aluminum sleeve over it. And these will catch any metal chunks that may exist from regrinding plastic or something like that. And in fact, I can see gray dust that was stuck to the magnets. Like there, you can see some.
Oh, yeah.
So,
it's doing its job.
Yeah. Because the worst thing is to have a little chunk of metal go through your screw auger and then clog the injection nozzle of your molding machine. So.
Oh my gosh, nozzle clogs are the worst.
Yeah, especially if it's a piece of metal, because you pretty much have to pull the nozzle off and then drill out the jammed up piece of metal on the inside of your nozzle. So, but as you can see, there's some age on all this stuff. Well, but the magnets don't wear out.
I guess even if you have smaller shrapnel than the diameter of the nozzle, it braids it. It's not good for the parts.
Yeah, it'll scratch your barrel. It'll scratch your screw.
Right.
But it will go through. But if
that's not
if your chunk of metal is bigger than the nozzle, then you're down.
Yep.
Anyway, so we'll put that back. So that was cool. All right, so yeah, we're still starting up this machine. The way I got it was the original switch was gone, and they put this huge circuit breaker in there. So we'll flip this thing on. It's not quite OSHA, but we don't have employees. And yeah, that's how it is at the moment. We're gonna clean that up though. I'll probably get an actual interlock switch, just to make it look good in case the fire department ever comes to inspect again. Here's the temperature controller we were using for the mold. There was a heated element in the mold, so which was a 240 volt heating element, and this is a 120 volt temperature controller. So the output of the temperature controller was 120 volts, and we put it into this step-up transformer to get 240 volts out. So basically, well, I think it's still on. Oh no, it's unplugged. Anyway, so this is a good way to fix your impedance on your heaters, is to have one of these simple step-up transformers, 120 volts to 240 volts. And that gets what you need.
I like your collection of mold release, by the way.
Oh yeah, well this is not sponsored, but this is mold cleaner.
Yeah.
And then this is the paintable mold release.
Yeah.
So after you mold your parts, you can run your parts through a dishwasher and all the mold release will get washed off. And we got WD-40
Yeah.
for lubing ejectors, and then the Napa wheel bearing grease for really lubing your ejectors. And then regular way lube inside of here. So this is the kit. We've got the brass needle nose pliers for pulling out stuck screws.
Well, and brass because?
Like this. Oh, because brass doesn't scratch steel, like hard steel,
Okay.
but it will scratch aluminum. So, I mean, you got to be aware. Yeah, so this was the kit. All right, so here is our controller. And like I mentioned, we're going to close the platens so that you don't see the customer's IP. Okay, so we can turn the motor on. Now this molding machine is approximately 20 years old, so it uses an induction motor, which uses a lot of power and runs pretty much all the time. It will shut itself off if the machine's idle for more than like 5 minutes or something. But that one big disadvantage of this molding machine is it doesn't have a servo drive like modern machines do. So it consumes a lot of power, and when it's on, it just seems like it's got a lot of just surging power throughout the whole building. You know, the whole room gets hot, and it's like furious power that this thing is cranking on.
Well, so maybe just for context, the servo style versus the induction style, what would you say, 50% difference, 70% difference?
Yeah, I would say the servo drive machines, modern ones, use about half as much electrical power as the old induction motor ones. Because this is a 75 horsepower, I believe, huge induction motor. You know, it's like this big around and like this long, and it just exudes power when it's running,
So
which means that your electric bill goes way up.
Yep.
But the trade-off is like to buy a new 500 plus ton molding machine with, you know, like this year with a servo drive and all of that, is probably $250,000. This machine I bought for about 10% of that. So I figured the electric savings does not offset the massive
CapEx
discount that we purchased this for. The other thing to consider if you have a small business is you owe property tax on equipment like this that you buy. So the power consumption of this 75 horsepower motor running all the time, which draws 30 amps as its like idle power at 480 volts, is still cheaper than paying the county the property tax if you were to buy this new, you know, because you owe 1.5% on $250,000 for basically the next 20 years. Whereas if you buy it for 10% of the original price, the power that you're wasting on an old machine is not as much cost as just the property tax that you would owe on a new machine that uses less power. So it's a little counterintuitive. Business property tax sometimes results in less environmental friendly options for businesses.
Yeah, but to be fair, our power is environment. Like we have a certain percentage of our power that comes in that is environmental.
Correct.
Wind, solar, and all that.
Yeah.
We're not straight up.
Yeah, we're on Silicon Valley power,
Yeah.
which is like I want to say it's like 25 cents per kilowatt hour. But if we were like in San Jose, then we'd be on PG&E, which is like 55 cents per kilowatt hour. So the figuring out where you stick your business, power consumption or power rates is important. So the city of Santa Clara has a ton of molding shops and a ton of machine shops
Because
the electricity is so cheap.
Yeah.
And it's almost all renewable too. And you're actually buying the power from the city. They have their own municipal power company. So anyway, that's maybe a rabbit hole, but anyway, let's fire this bad boy up. So we hold down the motor button. Oh, I forgot to turn on the cabinet. So you gotta hit the green button there first. And now we hit the motor button. There we go. That extra little jolt that you heard, I think is a clutch that engages the hydraulic pump. So the machine will freewheel the motor to allow it to spin up, and then it engages the hydraulic pump after that to help it with its inrush current to starting up. All right, and now we're going to close the mold. And again, don't look in there. So I'll hit the mold close button after you make sure everything's clear. Let's see, move ejector to back limit. Oh, ejector back. Okay. Oh, the ejectors were forward for some reason. Okay, now we'll do mold close. It'll tell you what, give you hints on the screen. There we go. Okay, so we closed the mold, so now we can look in there. And I'm gonna open the mold slightly. So if you watch the toggle clamp, we're actually not locked up right now, but I'm gonna back off the mold a little bit because we got to pull this mold to do some modifications to it. Yeah, so that's it. I do have some footage of this machine opening. Oh, we can turn the motor off now. And another thing is, this machine is set up for Asia OSHA or China OSHA. So the first thing that happens before the mold is about to open is that this door fires open. It's got like an air cylinder. So this door completely opens so that the operator is exposed to all of this, and then the platen opens, which is the way China safety settings are set so that the operators can reach in while the whole platen and the toggle clamp is in motion to shave off a few seconds in semi-automatic operation. So you can reach in and grab your part while there's still massive motion in the clamp itself, which is totally not allowed in the United States. But this machine is set up for the China OSHA style. And the guy that I bought this from said, yeah, they just set the settings to China OSHA, because this originally came from Korea. So there's two modes of operation, and I guess we don't have employees, so we don't have OSHA concerns because we don't have to worry about employee safety supposedly. But it's a little disconcerting that the door flies open and everything is moving and you can reach in here and grab stuff. Now, the machine won't allow the clamp to close, which is really dangerous, unless this door is closed. So for the next cycle, the machine will actually close this door, and then the clamp will close to do the next molded part. So that's a little interesting thing, and a little bit to get used to. All right, so I'm going to unclamp this mold. So basically these clamps will be released, and then we can pull this mold off with the gantry crane hook. And I've got to do some updates to this mold.
Maybe can you point out where the hook connects to the top of the mold?
Oh, yeah, there's
That's kind of interesting.
there's some lifting rings. Actually, you bought some more of them. So a couple of lifting rings will be screwed into the top of this mold. And then, and then there'll be a chain between the two to help distribute the weight. And the chain will also keep the mold halves together when we're lifting it out of this platen area.
Oh, okay. I think I see the two holes. And then we have the handy dandy
And we lift.
hook.
And I gotta keep the hook as close to the mold as possible because this is the maximum height right now. because we can't go any higher on the winch. Now there is a way to hook directly onto the lifting chain, but when you do that, you lose half of your lifting capacity. So we can gain about 8 more inches on lifting height if we bypass that pulley and hook, and we rig with a a rigging chain that has like the chain link hook. If we grab right onto the main pulling chain up there, then we lose the 2x lifting capacity because the pulley is no longer in the story, but we can lift another 8 inches. That way the maximum mold weight that I could load into this machine would be 1.5 tons because a pulley doubles the lifting force. So that is an option, but we'd have to be careful about making sure that we've got proper chain hook structure, and we know that the chain that we're using can handle 1.5 tons, because this is an aluminum mold, so aluminum weighs like 1/3 as much as steel. So if we were to load a steel mold in here that's this big, it would weigh like 3,000 pounds. We're back after doing some molding. We're back to pulling this mold out of the molding machine, and I probably didn't mention first round, but the lighting, there used to be another strip of lighting along this side of the shop, but with this gantry needing to be basically all the way to the top of the girder, I pulled the lighting out, and we're gonna have to figure out where the lighting is going to go. It'll be broken into 2 segments and tuck up in the space between the girder and the actual top of the ceiling itself. So that's something that needs to happen, and it's a little dark at the moment, but yeah, sometimes you got to do these kind of things. Okay, so we're going to move the gantry to get the hook onto our chain with the eye bolts, and these wheels are locked to go in one direction at the moment. And it almost runs like it's on rail, and I'm considering actually replacing these dolly wheels with actual like metal locomotive wheels and put track in the concrete itself. We'll see how that works out. All right, and then we got our crane hoist here, which is a very slow gear ratio. And we'll bring it down and hook onto our mold. Get it past, I guess, the chain itself. Hopefully I have enough chain links where this hook will fit. I think I'll go around to the other side.
Oh, I did notice that you're using a spring return method on this mold.
Huh?
You're using a spring return method.
Oh, yeah.
So you're just going to make it taut, right? Because then you'd have to unbolt to the platinum. Okay.
Taut without actually busting our chain link.
Yeah.
Oh, can I reach? Let's see if I got a cheater tool. There we go. You gotta watch chain links. Sometimes they can get in weird states. These clamps. I actually borrowed someone's torque wrench, and now it's not here, so I had to put a cheater bar on this Dymalloy steel, made in the USA, from the Diamond Cock Horseshoe Company in Duluth, Minnesota. So
wow,
this is an old tool. But yeah, I need to get one of the 2-foot like torque wrenches, because we need torque a little higher than what a hand tool will generate. But again, I pre-loosen these with a cheater bar off camera. And this is a spring return mold, so there's no tie bar that attaches to the ejector plate in the back, which is back here. So these bars right here, pierce through the whole platen and then just push on the ejector plate in the mold. to
Right.
compress those springs, but
Yeah.
we're not positively attached. So it's a spring return mold, which I think you fired off some debate on Reddit recently about that. Okay, and then these clamps are in the T-slots, which is really nice because this mold is asymmetric on the platen.
So maybe just maybe just highlight like where they lined up,
Yeah, the
like on the second one you pulled. Right?
yeah, or I can just. So this T-nut on the bottom of the clamp
Yeah.
will fit into this T-slot right here.
Oh.
If we were clamping from the side, but we're clamping top and bottom on this mold. So there's T-slots all the way around,
Gotcha.
which is saves a little bit of time and allows for an adjustable mold too.
Which is super nice.
But it can just slip out. So when I loosen this clamp, I need to have one hand on it because it'll probably just fall straight to the floor.
This is what, 1 of 4?
One of 8, but 4 on the
Four
B
bottom?
side.
Oh, 4 on
Or
the B
the
side.
eject side. But since the mold is fully suspended now by the crane, we can just take everything off. Okay, we're on the other side and I pulled the other clamps out. So we are ready to open. So we'll close this. Oh, I gotta close the back door. Pretty much all molding machines really don't want the back door open where the operator can't see if someone's getting smushed or not when they're running on the front side of the machine. Okay, so we'll hit enter to wake up the machine. And the cabinet's still on, so we can turn on the motor again. Okay, now what we're going to do is open the platen slowly, just to make sure we're not hanging up on anything. So we'll hit the mold open button if you want to watch what happens this direction. Okay, we're going to hit mold open. And you'll see the toggle clamp kind of collapse in the back. I want to see if we can do this with the door open. No, we can't.
Ah,
Only in semi-automatic mode.
safety.
I guess, yeah. Okay, so we're gonna keep opening the platen.
Okay.
Okay.
So,
And
mold is closed, and we have pulled the platen back.
Yeah. Okay, and that's it. We can turn off the motor.
Okay.
Open the door. I don't have the compressed air on right now, so I gotta kind of push against the piston.
So we're gonna.
And then I'm gonna push our gantry back a little. And the mold should separate. Or I gotta lift it up. Maybe I can jiggle it off. It was a little tight going in, so.
It's full off, right?
Huh?
It's full off.
It's unbolted, yeah. But the alignment ring was kind of a tight fit. So let's see if we can knock it loose. With a hammer and a rod. Any luck?
Well, it looks like, yeah, you got it to wiggle a little bit.
Yeah, it's coming. Maybe we'll pull on the gantry and see. Huh. All right, I can try prying from this side too. It's close, but it's real tight. There's a lot of schmutz on that ring. I'm using these T-slots with a bolt inside of it as a fulcrum. Oops, there we go.
All right.
So another good use for these T-slots is a little high leverage fulcrum point. Okay, I think, so this rolls pretty easily. I got the balance wrong, so because there's a slight natural hang and it's rolled. So in the future, I'll have to work on the balance better. Oh, there we go. Then you gotta check your cables, make sure you got enough travel. And usually with these winches, the control box has a high tension steel cable. And you use this control box with the cable to actually pull or let slide your mold on the trolley up there. But I think we're centered pretty good. So we'll just lift this thing up and out of here.
Now we've got clearance so that we don't damage the ways on the machine.
Yeah, it's just kind of kissing it. But we can push forward and get it off of there.
Oh, it's rotating.
That's fine, it'll do that.
Okay.
Rotating a good amount. And we basically need to clear the top of the sheet metal, the bottom edge of the mold. Needs to clear the sheet metal. So I actually lost like 1 inch because the mold is not hanging square.
Yeah.
But you can see up there we got
Oh, you're almost to the top.
just about 2 inches left. It'll automatically stop, like right there.
Okay.
It's got a shut off switch so it doesn't pull itself apart.
Nice.
All right.
We need that.
And then I'm gonna lock these wheels. So this down here, this tab, you can lock the wheels to be straight or freewheeling. So I'm gonna lock the wheels so that they roll straight. All right, here we come.
Wait a minute. Hold on.
I might have to go to the other side. Go back and forth. If we're hung up on something over here.
Ah, there we go.
Oh yeah, I'm on the bolt of the robot now.
Uh-huh.
All right, this is gonna drop 1 inch.
Okay.
So this is where the train track and trolley wheels would help keep this thing square.
Oh, that is a weird experience to have that mold coming at me like.
See there, I just hit a
Okay.
screw.
Okay. Oh. Man, your clearance is,
Tight.
yes, very tight. Actually, you might check it.
Oh, I'm on this stair hose right here.
Yeah, but you might check it because you're angled down.
Oh,
the
the sheet
corner.
metal?
And from my view, you look like you might be flush. Maybe just check it.
Yeah, I got about 3/8 of an inch.
Ah,
This bolt head right here
okay.
but we hit this air hose right here. I'm gonna have to rearrange this table and get it out of here.
Oh, yeah. Ooh. Ooh.
Oh, and
Oh, you made it.
you always gotta watch your cables too.
Oh, you got bound up? Oh, I see. The cut. Yeah.
There we go.
Yeah. Okay, but looks like you're clear.
Look at that.
Woo! Pretty nail biter. Okay, so now you can tell the crane is. It was down there near the halfway of the molding machine, but now it's way up here. I'm having to move myself a bit.
All right, I'll drop it down.
Okay.
It's not good to be under load.
Nope.
All right, coming down. kind of got bound up on the wall right there. So this table's got to go.
Yeah.
That way we'll have a little more travel room, or I'll put the track in, basically.
Well, we have a good piece of floor right there.
Oh yeah, you and I cleaned all the paint off this floor.
Yeah,
This
we
is
did.
Some black pad printing ink. I don't see any new cracks either.
Okay, so just so the audience knows, you see how shiny that floor is? I hit that with a paint removing die grinder many years ago. Okay, so Dave is guiding that down
Very slow winch,
very slowly.
which is nice for lining up your mold. If
Yeah.
your winch is too fast, you always overshoot the alignment range. Actually, I'll spin this around so you can see the alignment range.
Well, maybe not spin it
Maybe
too.
not.
Yeah. You might hit
Or we
that.
can bring the platen forward some more.
So the reason he can't spin it is that although he's clear, let's see if I can get him.
I got crap, too much crap.
He's clear, but he's got some facilities that he can run into if he rotates. So that's why he's not needed to get a little bit more room. Okay, so that's where the injector,
This is the alignment ring.
goes.
And then there's an insert on the platen, which is slightly recessed, which is a replaceable key in the platen itself. But here you can see the forces, how they distribute it, because you can see the burnishing of the aluminum.
Yeah.
And so pretty good distribution of force. This is a mounting tab here. But you know, there's not a whole lot of impression. Well, there is some right there. Yeah, and then this is just some burn from the plastic itself. Yeah, anyway, it's kind of cool to see read the mold phase, to see how square you are. And this wasn't fly cut, or this wasn't machined flat, but it's a high grade aluminum that supposedly comes flat, and it's within like a thousandths or two. Anyway, and then on this side,
You don't have to rotate. I'll come.
oh okay, you can see this is a hole for a pedestal or a pillar. So inside of this mold, there's a support pillar, a steel 4-inch by 1.5-inch pillar that is right here and right here, right here and right here, right here and right here. So you can see a lot of the force from injection actually accumulated right at the pillars. And I need to add some more pillars in here because I was getting some flash. But yeah, you can see the impression of where the force is concentrating right at the pillars, which pass through the ejector mechanism and then support the actual mold block itself that has the cavity. That's kind of neat. And then these are the T-slots in the mold platen itself. Kind of the clear grooves. That's where the T-slots for the adjustable clamps can go. And then these are T-slots here and then down there. Okay. So now I'll just pick this mold up myself and carry it over.
Yeah.
The one disadvantage of our setup here is I can't drive the forklift into the front.
Mm-hmm.
So along this edge, once we clear out all of the air compressors, I should be able to drive the forklift in and then drop a mold right next to the big yellow robot right there. For like the big steel molds, the 3-ton molds. And then this gantry is gonna probably have to be on steel rail at that point, and then we'll roll the mold bits here, assemble all of the molds in this location, and then lift them up and over and into the molding machine. So that's the plan.
Cool.
Anyway, so that could be a wrap for this week. As you could probably see, it's been a very busy couple of weeks and haven't had any videos, but we wanted to give a quick update for the shop. So hope you enjoyed this update for the molding machine, and I'll see you guys, or we'll see you guys next week. Thanks for watching Dragonfly Engineering. Goodbye. Figure it out. Okay, I will